All right, hello everybody. Again, my name is Emily Hefty Dieckhoff, and I am a water quality scientist at a small testing firm. We are a private water lab and also an engineering consulting firm in Mount Horeb, Wisconsin. As a first question, for a show of hands, who has heard of biofilm in the room? Oh, that's a lot more people than I thought. Okay, that's awesome. So we're going to start with an overview of what biofilm is, common issues caused by it, and then we'll go over some strategies to address biofilm issues. To begin with, biofilm is a really complex mixture of polysaccharides, proteins, enzymes, and bacteria. It's usually a stress response in response to the bacteria trying to protect themselves from their environment. That might be the case because they're starved, they're limited on nutrients. Another instance is, say, if it's a chlorinated system, that chlorine is supposed to try and kill the bacteria. Bacteria will do whatever they can to basically protect themselves from that. Now, this picture is actually a distribution main that was cut out of service the day before it was sent to us, and it was actually in use right before it was removed. So you can see a really defined layer of this gooey substance, and that is biofilm. Another example of biofilm is actually the plaque on our teeth. That's another example that you might be a little bit more familiar with. Now, biofilm forms because every water source has bacteria in it. There is no such thing as a pristine, bacteria-free water source. And so there's bacteria in the water that basically attaches to a surface, such as a pipe. And then there are a combination of bacteria that then continue to form this biofilm, this substance that protects themselves. And as that community grows and diversifies, there's some layering effects. And then also, as microbes are limited on certain nutrients, such as metals, it could be phosphorus, it could be sulfate, it could be a variety of things, they will sometimes cause microbial-induced corrosion. Basically, the bacteria will attack pipe surfaces, and then there will be corrosion materials such as lead and copper that also incorporates in that biofilm. Now, there are events that happen that cause that biofilm to slough. It's a disruption event. One very well-known example of that was actually the water crisis in Flint, Michigan. So that system had a long history of, there were lead service lines and whatnot, and lead had basically formed into the biofilm in those distribution mains, the service lines and whatnot. Well, when Flint, Michigan changed their water source, that was a huge disruption to what was in the system that caused the sloughing event, and then we had that public health crisis where there was a huge lead release. Since we're at a private well conference, I wanted to start with wells first. Biofilm can be found in all components of a well. And what I wanted to direct you towards, this is a very basic diagram of a well. And we have, it's the SWL, the static water level. That's where the water level is going to sit when the well is not pumping. And then we have DWL, which is dynamic water level or pumping water level. And then when the well pump turns on, the water draws down, and then it's at that lower level. So every well is constructed differently, but the more that water sits stagnant, if there's not a very large drawdown basically between those levels, that can be an area where biofilm forms. We also see it in column pipes. We see it in the dead zone between the pump and the dynamic water level because really the water is not moving very much in that area. Then we also see it in the casing because oftentimes that will be metal, and as bacteria need metals, they will cause corrosion in that. We see it in the borehole. Now, this is going to be natural minerals that are in that geology. One really extreme example we dealt with at WQI was actually a community that was out of compliance with radium. We determined that there was a significant amount of biofilm built up in the borehole of their well, and the bacteria were actually eating away at the borehole materials and releasing that radium. Once we did a really intensive mechanical and chemical cleaning on that well, it was actually brought back into compliance with radium. Some wells have screens that can be a portion where the biofilm forms, and then also the aquifer. The aquifer is a place where bacteria can also create biofilms. In other cases, it may just be the aquifer itself that's challenging, in which we would request that treatment is installed. Now, beyond wells, distribution sites have a lot of biofilm growth potential. Dead ends are basically the ends of pipes that are not really in use, and that's where a lot of stagnation occurs. We also see areas with low use, low turnover. For instance, if we have a home where it's an older couple, they don't use a lot of water, they may have had kids at one time, and that water level or water usage has changed. That is a prime area of growth for biofilm. Reservoirs and water towers, as well as distribution mains, just like that picture I showed earlier. Now, once we move into the plumbing system, it gets kind of tricky, because if we were on a public system, the utility is responsible for everything up to the service line. And once it's the service line and beyond, whether it's a commercial building or a private residence, that's the owner's responsibility. Water heaters are a significant source because it's a really hot environment, and that can really select for some bacteria. Softeners, filters, any sort of media is something that we have really seen a lot of biofilm growth. The reason being is because there's a lot of surface area in there for biofilm to grow onto, and also it's going to get backwashed and regenerated, but that's not always strong enough to remove biofilm that's growing in that. We found biofilm in all pipe materials, whether it's PVC, PEX, copper, galvanized. It just basically changes the structure of the biofilm because it's searching for something different. We see a lot of biofilm growth in fixtures, specifically showers. One such area that we've seen a lot of issues with, for instance, in a hotel, is in ADA accessible rooms. Those usually are not booked regularly, and so the shower fixtures basically sit and they're not drained. They have water sitting in them, and that can be a huge factor for Legionella. We see a lot of growth in service lines. I'm going to touch on that a little bit later. And then fire suppression systems are also a huge area for growth because water is just sitting stagnant in those pipes constantly. Private and public systems don't test for biofilm. I'm sure none of you have really considered testing for biofilm. And while systems test for inorganics like lead and copper, organics such as TOC, and also coliforms and E. coli, we don't test for all those things together. In short, regulations don't address biofilm. Now, here's some really extreme issues. These are actually all examples from Wisconsin. We do work all around the United States, but I wanted to kind of bring it home and show that this is in our communities and in our homes all over the place. So on the far left, you might be wondering what that is. That's actually a well pump from a municipality, and the municipality had lost capacity to pump water. When they pulled the pump, they thought it was just going to replace it. They found it was actually completely covered with this slimy biofilm material, and that it basically shut off its capacity to pump. In the middle picture, you'll see a distribution main that had just been cut out of a hospital water system, and they had a lot of tubercles, and there was, again, microbial-induced corrosion. The bacteria were short on a nutrient, and then they were targeting those pipes. Now, if you were to try and do a water management plan and incorporate flushing in there, imagine how hard it would be to get Legionella and bacteria out of that. It'd be a constant struggle. On the far right, we have an example of a filter that was actually in a residence, and the resident would install the filter, and it would take about 2 weeks, and then this sludgy brown material would basically prevent it from filtering anymore. So I wanted to show some very different examples of what biofilm looks like because it's not necessarily this slimy, gooey substance all the time. Biofilm can also house pathogens. I will say that biofilm is everywhere. Biofilm is not always a problem, but when biofilms cause corrosion, they cause aesthetic issues, and they house pathogens such as E. coli and Legionella, that's when they're a problem. In the case of this picture, we had a resident that had repeat coliform positives. When we went out to their home, it was kind of interesting because they had shock chlorinated their well several times, but in the home, I think it was at a kitchen tap, they were still testing positive. It was interesting because they had clear PEX plumbing. We were able to look, and there was actually visible biofilm growth in there. That's what was in there, and that had gotten in there because of prior well events. And when you clean the well, but you don't have a way to clean the plumbing, you still have all of that bacteria in your system. One thing I wanted to add that we find extremely helpful is on the left, there's a picture of a Quantatray. Our lab is certified for coliform testing with the IDEX ColAlert method. I'm not trying to endorse a specific product, but what I am trying to say is we don't recommend presence-absence testing. It doesn't really give us much information if you have a positive. We don't know how severe the problem is. So this tray is actually a way that we are able to statistically count how many bacteria are in that sample that are coliforms and also E. coli. Now, if we get a sample in that has a count of 1, we might suspect it's a sampling error, or it could be an overabundance of total bacteria, and that causes false positives at times. But when we have a sample that looks like this, we definitely know there's a problem. Biofilm can lead to shock chlorination ineffectiveness. We've had cases where residents come to us and they have shock chlorinated their well 5 or more times and they are still coliform positive. That's because there is a layering effect of the biofilm in the well. Remember when I showed you how biofilms are formed? It's not just one type of bacteria, it's not just one layer, it's all different kinds of substances. And so when you basically strip a layer, you might have a higher coliform count after a shock chlorination. And that's because those bacteria on the next layer are now exposed. We found that well treatments are a lot more effective if there is a mechanical aspect to help remove some of that material first. Not only does it make the chemical more effective, but it also makes the chemical dosing potentially less, and you use less chemical. Chlorine alone is something we found is not effective in all cases. Number one, it's more effective at a lower pH. We see it being effective at a pH of around 6, at least below 7. When we add chlorine to a well at first, that pH can go up to a pH of 9, and then it's not able to break down the cell membranes and whatnot. It just kind of maims them, might injure them. It doesn't kill them. We also recommend having a high enough residual. We tell our pump installers and well drillers that do treatments with us that they need to test the residual, and if they've used up all their residual in the first round, we need a stronger dose. We also recommend recirculating. We often advise using a tank, sometimes it's 400 to 500 gallons, and then we have it pumped in a circle so that it's not just in one area, it's circulating during that treatment. And again, that might lead to redosing because as you circulate, you're using more of that residual. Chlorine is something that is meant to disinfect. It doesn't mean that it cleans. So what I mean by that is, in the picture, we have an example of a column pipe that was pulled, and chlorine alone wasn't going to take care of that problem. It might kill what's on the outer surface if it can penetrate those cell membranes, but it's not going to remove that substance without an acid to help. A lot of you are probably familiar with aesthetic issues that happen, discolored water, people have odor and taste issues. One thing that is easy that we like to do when we go into a residence, we'll often pull the cover off their toilet tank and look at that, because I will admit I don't clean my toilet tank. And so that is an area where water is going to sit and it's not regularly cleaned. It gives you an instance of, am I smelling a sulfur smell? Am I smelling something else? Is the water here red or brown or something like that? Aesthetic issues are largely caused by certain groups of bacteria. It certainly can be a symptom of an aquifer issue if there is high iron or manganese in the water, but bacteria are a big part of aesthetic issues as well. Iron bacteria cause red and brown biofilm and staining. They're usually present in waters with high iron, and they create biofilms for protection. Now, when we see a biofilm that's kind of a reddish brown, it's often because they're gathering that iron into their biofilm, and that's what's causing that coloration. We see sulfur bacteria. They often cause rotten egg odors, black specks, or black water. They produce sulfate in an oxygenated environment, sulfide without oxygen. We see them a lot in water heaters and hot water systems. Ammonia oxidizing bacteria are often present in water that looks clear. We all know that clear water doesn't necessarily mean good water, but that does still mean that there's bacteria in the water. And so if we have nitrate or ammonia for those bacteria to work with, they can convert those. And in one case that was really interesting, we had a residence that came to us. They said, we have a nitrate problem. We wanted to test, and so we actually had them grab a sample from an upper portion of their well and a portion from after pumping their well for about an hour or 2 hours. So that was more of an aquifer problem. What we saw is that the nitrate was actually close to 12 in their well, and it was close to 5 or 6, if I recall, in their aquifer. And so we advised them to do a well cleaning, and I think it's just amazing how much I've seen that doesn't seem like it should be possible, and it is. But then they actually didn't need to do nitrate removal because we took care of the problem that was happening in their well. Moving on to strategies to address biofilm issues, the primary thing that we advise is that you need to test, and that's going to help you assess the problem, determine the cause, and develop a solution. On this image here, this is what we call our highly sophisticated bucket test. We have 5-gallon pails that are white, and we basically line them up next to the raw water tap, and we don't want treated water at this point, so that's why it's well water. And after the well has been not running for a certain period of time, we'll then create water demand so that the pump is running continuously. And then we'll fill up a bucket every minute of pumping, basically. So this would represent 10 minutes of pumping. You would guess that water would look the same from a well, as long as it's the same well and pumping rate and whatnot. But what we found in this instance is that the upper portion of the well, probably in the cased region, that'd be about the first 4 minutes of pumping, was creating some corrosion issues, and that was causing the discoloration that this homeowner was experiencing. But when we pumped it for longer, we could see that the aquifer wasn't necessarily the issue. So we could hone in on where we wanted to test because budgets are limited. We usually have to work with less samples versus more. And so by targeting a specific area, we were able to say, yep, this is biofilm, this is how you need to treat your well. It's really difficult to figure out the cause of what a biofilm issue is. We're working with a lot of different factors, such as the well, we've got the aquifer, we've got the location, and that would also include geology, plumbing materials, oversized plumbing, water usage, age of system, external contaminants, prior well treatments, treatment equipment, others and combinations of these things. We have internally tried to create a decision tree to help us figure out what problems are, and it is basically impossible because every situation is so unique, and that is a huge It can be a fun challenge, but also a frustrating struggle when we're trying to help people. Our company is not funded in any way or form. It's a private entity trying to serve the public. And so when we're working with limited budgets, people who don't really want to try something new or think about it in a different way, it's a real challenge. Flushing is a way that we can address biofilm. In this case, this was a municipality that we worked with. They had been having some lead and copper compliance issues. And so what we wanted to do is we had looked at their distribution system, but we also looked at their service lines. And so for lead and copper samples, it's a 6-hour stagnation. So the first picture is basically a bucket that receives stagnant water after 6 hours of stagnation. And then what we actually had the utility do is they installed a flushing port off of the water meter, and then they were able to create a lot more ability to run water at a faster rate. So I think they were actually at about a 15 to 20 gallon per minute flow rate. A lot of homes we actually see are closer to 3 or 4. So it doesn't disturb what's in the service line. When they did that, this was the result, and that didn't clear up for several minutes. We've done some really interesting work with some municipalities in Wisconsin where in one case, back in the 50s or 60s, I think they had an alum treatment type system where they were adding aluminum in the water. Hadn't done that since the 60s, but we tested a house that was from the 1940s, so it would have seen water from that era. And when we did this service line flushing, they had really high amounts of aluminum, and no other house had that we at least had tested. And so it was all trapped in that service line from years and years ago. Something else we like to advise is flushing water heaters. This was an instance where we were in a commercial building and they had some water heater failures in a relatively short amount of time. We were finding that because it's a hot environment, materials settle to the bottom. There's a lot of accumulation that happens. So this was the first liter basically of the flush of the water heater. A homeowner can do this, commercial buildings can do this. We'll sometimes recommend they do it monthly, and as things clear up and they don't have as much color, they can decrease that maybe to quarterly. But not only will it improve the safety of the water, but it will also hopefully extend the lifespan of that water heater. Hydrant flushing is another form of flushing that we recommend. One practice that we also work with utilities on is unidirectional flushing. We'll create a plan based on where their valves are placed, and then we'll have them close certain ones and have other ones open so that we can direct a much larger volume and velocity of water so that we get more scouring. Well rehabs I've touched on a little bit. We recommend a mechanical aspect that usually is with some sort of brush, and it basically goes up and down in the casing to try and remove material, followed by a chemical rehab. We like to test before we recommend well rehabs because we customize them for every place based on what we're seeing. So that's going to basically influence, are we going to use an organic acid such as citric acid? Are we going to use an inorganic acid like muriatic or also known as hydrochloric acid? What kind of chlorine dose do we need? How do we need to dose it? That's such a thing. And then we also need to consider what needs to be cleaned after the well. Remember that picture of the house that had the coliform issues. They still needed to do some sort of basically cleaning process in their plumbing to get rid of what had been produced by the well. When we're looking at treatment, we need to make sure it addresses the problem and not a symptom. So this is an instance where the homeowners had originally, when they built their house, not had any discolored water issues. And then over time, they were an older couple, they didn't use a lot of water, and they were noticing that they had really brown water. So I think probably 10 or 15 years ago, they had been advised to put an iron filter system in, which is what you see on the right. And then when we went to their home, we did a bucket test. It looked like, yeah, you have an iron problem. And then we did an interesting thing by pumping the well for 2 hours. And then the bucket that you can see in the middle is actually what was produced by that. So it was telling us that their source actually might not be the problem. It might be that we discovered later there was a lot of extreme corrosion in their casing, and that was causing this discolored water. So after treating the well, they didn't necessarily need that iron treatment equipment. Perfect, thank you. So to wrap up, biofilm isn't widely known about or accepted. Our regulations don't address it. We don't have testing through labs, but if you talk to me afterwards, I can try and help you with that. Finding well drillers and plumbers and pump installers to do treatments that are not necessarily what the industry says is really difficult, and we don't have one-size-fits-all solutions. We need to consider water quality aspects from multiple perspectives. The theme I've heard at this conference is better together, and that applies here. We need to collect and compare samples from a source to tap approach to figure out where exactly the problem is occurring. And then we need to not underestimate biofilm and bacteria. I'd like to thank the conference for the opportunity to speak, and I encourage you to look at our website. Give us a call if you have issues, and at this time I'll take any questions. Perfect. Are there any unofficial field style tests that homeowners can do if they think they have biofilm issues? So there are tests that are developed for that. One is called the BARTS test, and you can do different tests basically where you have a water sample in there and then you can see if there's some slime forming in there. It's something that takes 7 days. So what we've developed is basically some in-house proprietary testing that we can do in a day and come up with some results that are looking at different parameters. But as far as field style tests, there's not much out there besides the BARTS test. What inorganic contaminants are commonly released during a sloughing event? So the inorganic contaminants, they're largely tied to maybe what the pipe surface is. So if it was a lead service line, lead would be an inorganic that would be in that sloughing event. Copper is also something that could be in there. And then if there's any sort of, I had mentioned the example with the aluminum, that was something that was accumulated in the biofilm. So wherever they're touching a surface or getting something from treatment is where they can get that inorganic material. Would UV or continuous chlorine systems help with biofilm formation? Yes, that is something that we will advise in certain cases. If, for example, the aquifer seems to be a problem in a well and they're having continuous coliform problems, we have advised people to use a UV light for treatment, and that works pretty well. Continuous chlorine systems are something that we might recommend in a public system. We try and stay away from that for homeowners if we can, just because there's maintenance and there's chemicals, and that usually doesn't go well with homeowners. How prevalent are biofilm issues in wells? Any estimates on percentage of wells affected? So I would say that biofilm is in most wells. It depends on the different factors that I was talking about, how hard that well is used. We've seen dairy farms where they're not milking cows anymore, and they have a lot of issues with their well because they're not using water to the level that they once were. I would say biofilm is everywhere, but it's not necessarily always problematic. And as far as estimates, we have certain areas of Wisconsin that are definitely worse than others. So there are a lot of different factors for that. All right, thank you.